So this morning I thought, okay, let's talk about the origin of the Schrödinger equation. So the Schrödinger equation is what guides the evolution of the wave function, which is the most important thing in physics. And everything according to the Schrödinger equation, everything runs on probability. So as I've been talking about how space-time is composed of quantum state vectors, these little bits of light that are emitted onto qubits from entangled black holes. And the angle of that little bit of light, that little bit of Hawking radiation, describes velocity encoded on that qubit, and the rate that that velocity changes each moment when a new vector is emitted onto the qubit, the rate that that vector changes, that describes curvature or gravity, or the rate of information flow. But remember also how we were talking about how the cosine squared of that vector of light, its angle squared, the cosine of it squared, gives you the probability amplitude that tells you the probability that the qubit will be in a spin up or a spin down state, or a pixel that's on or off, or like a 0 and 1 in a computer. So the angle of the quantum state vector is what gives you the probability. And as you move through the curvature of space-time, and there are different angles of these quantum state vectors, that's different curvature, that's different, strength of gravity at each little point. But the angle also gives you the probability of the qubit being in a spin up or spin down state. So the quantum state vector, its angle, is what guides the evolution of the Schrödinger equation, because it is showing you the probability of how that wave function will collapse the next moment later. So if quantum information holography proves to be correct with empirical evidence, which I believe it will, then we can also show that the quantum state vector, specifically the cosine squared or its cosine squared, gives you the probability amplitude, which is what guides the evolution of the Schrödinger equation. So again, it's very simple, it's easy, it becomes complex, but it's beautiful, it's simple, and it answers many questions. It's the biggest questions that we've had in physics. For instance, where the Schrödinger equation comes from, what gravity is and where it comes from. And what gravity is just the rate that those quantum state vectors are spinning. I'll go into it a little bit later, but it also solves the black hole information paradox. And then we'll go into this a little bit later, how it shows the origin of mass. So I hope you all are having a great day.